You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Someone must have pulled some strings with the folks in charge of the weather. After some dramatic storms in Florida for most of the week, the skies on Sunday evening finally cleared up, and SpaceX's Falcon Heavy, a fully expendable version I should add, finally got its chance to light up 27 Merlin engines and launch from Kennedy Space Center.
T-minus 20 seconds to LOS egress. Go for deploy. Roger roll.
Today is May 1st, 2023. May Day, but the good kind. I'm Maria Varmazes, and this is T-minus. Falcon Heavy takes the first Viasat 3 to GEO. Musk gives a Starship update. Shaken up juice. China and UAE make some Mars discoveries. And my conversation with Tom Marotta, CEO of the Spaceport Company, on spaceports and the coming space launch infrastructure bottleneck. Stay with us. Now here is your intel briefing for today. The Viasat 3 mission lifted off from Kennedy Space Center in Florida yesterday with a 6,000-kilo Viasat broadband satellite as a payload aboard an expendable version of the Falcon Heavy, SpaceX's super heavy lift vehicle. Also part of the payload was the Arcturus, the first satellite launched for San Francisco-based SATCOMs maker Astranis, which will operate on the KU band and will provide dedicated internet access to Alaska. And the third satellite aboard is the Denmark-made G-Space 1 CubeSat made for gravity space. Now, as the name suggests, the Viasat 3 is the first of 3 new Ka-band broadband satellites for a new Viasat constellation that's being set to orbit in geostationary orbit, or GEO. In fact, all 3 satellites aboard are basically GEO-bound, and that's why this Falcon Heavy wasn't reusing its core and boosters as it often does. The GEO orbit for these satellites is about 35,786 kilometers above Earth. Now, compare and contrast that to LEO, or low Earth orbit, which is usually around 2,000 kilometers. So put it all together, with GEO being so far away and the fact that this Viasat 3 satellite is just massive, 6,000 kilos, as we said earlier, and 43.9 meters wide when the solar panels are all deployed, it's a third of the size of the International Space Station. Those 2 reasons are why this Falcon Heavy needed to expend every last drop of propellant to get the payload where it needed to go and could not recover the core and boosters. The benefit for the customers in this case is that the satellites themselves won't need to expend a lot of their own propellant to get where they need to go in orbit, so they'll have a longer lifespan out in space. The first of 3 Viasat 3 satellites was contracted to be launched by SpaceX, with the other 2 satellites going to ULA on a Vulcan 5 sometime later this year or early next, and Arianespace on an Ariane 6, respectively. However, given the delays in Ariane 6's development, Viasat says they're evaluating alternative launch options. Now, there aren't a lot of rockets that can handle the huge, heavy Viasat 3 satellites. Nevertheless, we'll keep an eye on what develops there. And another SpaceX-related development over the weekend, though not as dramatic as a launch, maybe. Instead, it was news straight from SpaceX CEO Elon Musk, who talked about ongoing plans for the company and the Starship Super Heavy on a Twitter Spaces conversation on Saturday. Now, he touched on a number of things, but we'll call out some highlights for you. Item 1, Musk says he expects to spend about $2 billion to further development on Starship and expects that the next flight of his Super Heavy rocket will go orbital. That $2 billion is presumably in hand already and won't need to be raised, says Musk. Item 2, if you notice that some of the Starship Raptor engines were out during launch, yes, that's true. But contrary to speculation that the debris from the launch pad may have taken them out, Musk says no. They only had 30 of the 33 engines actually ignite at launch on purpose. The 3 engines that weren't ignited were having some issues before launch, so they decided to move on without them. Plus, the Starship should be able to launch without all 33 Raptors firing, said Musk, so it was a way to test flight without optimal conditions. 27 seconds after launch, Musk says that ground control lost communications with one of the firing engines, and then 85 seconds into flight, SpaceX also lost thrust vector control, aka control of the rocket. One more timestamp for you. Musk says it also took 40 seconds for the autonomous flight termination system to kick in, which is not great for a rocket that is also no longer under anyone's control. So if you were watching Starship doing somersaults in midair for what felt like a long time, wondering how long it was going to do that for, they were too. So that's something that they definitely need to address before the next flight test. And item 3, the infamous launch pad damage and resulting debris mess in the surrounding areas. Musk maintains that the damage isn't as bad as it looks, and it didn't mess with Starship. However, he did admit that, they didn't mean for Starship's impromptu launch pad demolition to happen. And speaking of launch pad, let's go a bit east from Boca Chica, Texas, back to Florida at Kennedy Space Center. Teams at NASA are making plans for how to keep the launch pads there resilient from stronger hurricanes and rising ocean waters as a result of climate change. Launch pads that are especially close to the water and unfortunately especially at risk of damage. The historic and very busy launch pads 39A and 39B, which have seen the launches of the Saturn V's, the space shuttles, and many, many Falcon 9s and Falcon Heavies, and will be the future home of Starship. Within the last decade, NASA has seen ocean waters get within 2,000 feet of critical launch infrastructure at these pads. And as of 2019, NASA has spent about $100 million to fix storm damage and rebuild sand dunes to protect the launch pads. Upgrading coastal roads, continuing to rebuild sand dunes, and even planting mangroves are all big priorities from NASA and making this area more resilient to storm and wind damage. The European Space Agency says it plans to shake up the Jupiter Icy Moons Explorer spacecraft, known as JUICE, quite literally, in a bid to help full deployment of the onboard radar antenna. Now, ESA says that the 16-meter-long radar for Icy Moons Exploration, or RIME, antenna is being prevented from being released by its mounting bracket. A possible stuck pin may be to blame for the delayed deployment. Now, ESA says that they plan an engine burn to shake the spacecraft a little, followed by a series of rotations in the hope that the mount and radar will warm up and help dislodge the rogue pin. Forget oil and gas. Water will be the resource currency in space, and findings from China's Zhurong rover have shown that there may be more of it on our neighboring planet than we first thought. As we mentioned last week, China's Zhurong rover has yet to wake up from its planned Martian winter hibernation, but prior to going to sleep, the vehicle made some interesting observations. Studies of the sand dunes on the red planet show potentially fertile areas in the warmer regions of Mars. The findings were shared in a study published in Science Advances and claim that although the rover did not directly detect water or ice, conditions could be suitable for small amounts of water to appear during certain times of the year. And speaking of Mars, new images captured by the UAE's HOPE spacecraft support a theory that Mars's moon Deimos formed at the same time as the red planet and is not a captured asteroid as previously thought. Scientists are not quite sure how Deimos formed yet, but say that the images show that it is quite different from Mars's other moon, Phobos. The HOPE spacecraft will continue to observe Mars's moons until next year when fuel reserves are expected to run out. An all-female crew from Catalonia, Spain have just completed a 2-week simulated Mars mission. The experiment conducted at the Mars Desert Research Station, or MDRS, in Utah was operated by U.S. NGO the Mars Society. Mission participants were subject to the same sorts of restrictions that a crewed mission to the Red Planet would face, like limited access to water and communications with the outside world. The goal of the mission was to conduct scientific research and to inspire young girls and underrepresented groups to pursue STEM-related careers. Satellite operator Avanti has opened a new office in Lagos, Nigeria. The UK-based company says Africa is a major focus for operations and that they now have more than a fifth of their employees based in offices in Nigeria, Kenya, and South Africa. Avanti has invested over $800 million in Africa, providing connections to more than 1,000 villages and schools, and expanding services in Nigeria, Kenya, South Africa, Tanzania, Senegal, Ghana, Angola, Cote d'Ivoire, Cameroon, and South Sudan. The company plans to connect a further 10,000 sites over the next 5 years across the continent. Queensland-based rocket manufacturer Black Sky Aerospace has become the first Australian company to locally produce ammonium perchlorate, a chemical that makes up about 70% of most rocket fuel. The company's CEO, Blake Nikolic, says now that they have produced the chemical known as AP, Black Sky hopes that it will help Australia become self-sufficient as it aims to produce sovereign rockets and missiles. And a quick mention for you now, Cislunar Industries have been issued a patent for their space foundry technology for in-space metal processing and contactless manipulation. You can find out details on this story and much more in our selected reading section on our show notes at space.n2k.com. And that's it for our briefing for today. Now, T-Minus crew, every Monday we produce a written intelligence roundup. It's called Signals and Space. And if you happen to miss any T-Minus episodes, though why would you, right? But if you do, this strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. And you can sign up for Signals and Space in our show notes or at space.n2k.com. Now stick around for my conversation with Spaceport Company CEO Tom Marotta, and that's coming up next.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
As commercial space continues to grow, launch capacity is only becoming more and more of a pressing issue. Thankfully, there are people working on making more space for getting to space. One of those folks is Tom Marotta, CEO and founder of the Spaceport Company, which is building launch sites to service the commercial launch provider industry.
As many people know, there are more rockets and more satellites being built today than ever before. But in the United States, at least, there are still only 4 places where you're able to send a satellite to orbit. So we have all these rockets, we have all these satellites, but we have this bottleneck of an insufficient amount of launch sites. In other words, the demand for launch pads exceeds the supply. So the Spaceport Company is meeting that demand. We're building launch pads, and we're doing it in kind of a unique way. We're building launch pads on ships, on mobile offshore platforms. And we could get into why we're doing it on ships maybe later on.
I'd love to get into it now, if that's okay.
Sure.
Yeah, I
Sure.
think it's super fascinating. So let's get into that a little bit, because I think our listeners are probably familiar with. They've probably seen like drone boats,
Right?
So they're familiar with some of that. But let's get into that a little bit more about launching specifically from boats.
Sure. So as I said, there's this big demand for more launch pads to get all these satellites into orbit to meet the demand for data from space. Things like taking pictures, internet bandwidth, all the ideas of that satellites do. Building more launch pads on land has proven challenging. throughout the world for regulatory constraints. It's very expensive to buy the hundreds of acres that need to be built on the coast. These facilities typically need to be built on the coast. And biggest problem is there's a lot of community opposition to these facilities. Building anything in the United States is challenging today, but spaceports are particularly challenging because the activities that occur at a spaceport are loud, they're disruptive, things occasionally blow up, and many neighbors, many stakeholders in the existing stakeholders object to the construction of the spaceport on land. There are also, for U.S. launch companies where much of the launch development is happening, it's very challenging for U.S. companies to go overseas. The U.S. government has very strict export control rules on exporting what are essentially, ICBMs to foreign countries.
Yeah, ITAR, right?
ITAR, exactly.
Yep.
Exactly. Yep. So it can take literally years for a U.S. company to get approval to conduct a launch outside of the United States. And once they do get approval, it's very challenging for the launch company to close the business case for what is a very long supply chain, right? To transport a rocket, across an ocean to another continent. They can do that once or twice, but to do that scalably, repeatedly, it's pretty challenging to make the business case close for those expensive long distance operations. So what we're doing instead is putting the launch pad on boats and bringing the launch pad closer to the factories. We operate within U.S. territorial waters. And the way this works very simply is the rocket manufacturer integrates the satellite with the rocket on land, transports the rocket to any industrial port. So we're looking to operate initially out of Norfolk, or perhaps Port Canaveral, somewhere on the East Coast, but we could operate out of the Port of Oakland on the West Coast, or New York, or Providence, pretty much any industrial port. Rocket gets loaded on to the ship, and then the ship goes just 5 to 10 miles offshore. We don't go too far off. We can be in place in about 6 hours. Being closer allows us to have technicians and parts easily transported from the shore back to the ship. We can use microwave transmitters to have high bandwidth telemetry links between our offshore launch pad and the shore. And we avoid a lot of the export control rules by remaining in U.S. waters.
Okay, that's really interesting. Yeah, I was going to ask, I'm sure you've heard of people asking about sea launch. And, they tried it ages ago, but they ran into a lot of issues. So that's a really interesting way to do it better and to avoid some of the issues that they ran into with, because they were international, if I remember correctly, and there were some issues there, right?
That's right. Yeah. So I would push back a little and say that the Boeing Sea Launch System was actually a technical success. They conducted 36 launches. 34 of them were successful. They had mishaps that they came back from and then launched some more. The biggest challenge with the Sea Launch System was they had a very complex international partnership agreement. They used Ukrainian rockets and Russian expertise on a Norwegian oil rig, and it just didn't work out, especially after the geopolitical challenges in 2014 with Crimea. It just became an untenable process, but not necessarily for technical reasons. If they weren't partnered with Russia, they'd probably still be launching today, I think.
Yeah, so it's smart that you're avoiding a lot of those issues by just keeping it U.S. domestic, and I think that's a really smart move given the challenges there. And it's really fascinating to me to hear that you say that you can get the ship in place in 6 hours. That's a lot faster than I would have expected.
Yeah, that's right. So one of the benefits of being closer is we can get in place a lot faster, and we're designing our system from the ground up to be high cadence, high capacity, and scalable. So our first orbit-capable platform will be in place in 2025. Once we've worked out the kinks, we expect to just copy and paste that system and sort of have a standardized, repeatable launch platform that can then be used up and down the East Coast, on the West Coast. And eventually we hope to go international. I know initially I keep repeating that export control rules are challenging, but they're not impossible, right? We expect to eventually tackle that and overcome it so we can build a network of spaceports off the coast of every coastal city around the world, so we can replicate the success everywhere, and eventually lay the groundwork for what's called point rocket transportation, using rockets to transport cargo from one point on Earth to the other, in addition to using rockets to transport satellites into space.
Oh, what a cool vision. That won't that be awesome when that happens? That'll be so neat.
It's a ways off, but we are laying the groundwork for it at this point with our system.
That's really smart. So as you're building this, as you're scaling, because you guys are still sort of in the earlier stages, right?
Correct, yes.
So what kind of talent are you looking for to bring in to help make this vision happen?
We have a pretty unorthodox team because we straddle the maritime industry, the aerospace industry, and the regulatory world. So we've already built a team. We have experts from the Boeing Sea Launch System. We have experts from SpaceX that worked on their offshore operations. We have startup experts who have scaled startups to successful exits. We have a commercial shipping expert who worked with BP for 15 years managing commercial shipping fleets. I'm a regulatory expert. I worked at the FAA for 5 years. I helped write the regulations that underpin the launch industry.
Oh, wow.
But we need a lot more help. So we need people who know how to drive tugboats. We need people who know how to fix generators. We need aerospace engineers, the type of people who can do trajectory analysis and really high-level propulsion engineering. We need crane operators. We need truck drivers. So I'm really excited to be here in order to reach outside of the aerospace industry into the maritime and the automotive and the trucking and the mechanical and the aviation world and say, hey, we need all you guys. There's a labor shortage right now in the aerospace industry. And if you're at all mechanically inclined, if you know how to weld, if you know how to drive a truck or a forklift or a tugboat, you might want to consider looking at working in the aerospace industry.
Yeah, folks who maybe didn't know that there was a job for them in aerospace, there is. That's cool. Yeah, so it's not just ground crew. It's a sea crew in this case as well, which is really neat. Not something I get to say very often. So that's really fascinating.
Exactly. It's not your grandfather's aerospace industry, right? It's not just PhDs in suits in a clean room bolting together
not
$1 billion satellite.
There's
still plenty of that. Exactly. There's nothing wrong with that. But it's in addition to that, there's a lot more opportunity in the industry now.
Oh, that's fascinating. Tom, I really look forward to following up with you as the Spaceport Company continues to grow and scale. And I'm just fascinated to watch your journey. So please keep in touch and let us know how it's going.
Outstanding. Will do. Thanks, Maria. This has been a lot of fun. Talk to you soon.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
And welcome back. Now, space elevators are one of those fun concepts that can be fun to nerd out over, to me, kind of like a Dyson sphere. The potential would be amazing if we could actually build one, or if anybody ever could. Though I will say, if you've seen Apple TV's Foundation series, in an early episode, they show the rather spectacular result of what would happen if a space elevator failed. I have to say, it gave me nightmares. In any case, you can take a trip on a fictional space elevator thanks to Neil Agarwal on his website, Neal, NEAL.fun. And it is indeed fun and actually very educational. You start at the ground level and scroll and scroll and scroll and scroll and see what you might see if you were taking a real trip up the space elevator, with great illustrations and explanations as you go. And it takes so much longer to get up to the Kármán line than you would think. Now, thankfully, Neal provides some handy space elevator music to keep you company while you make the journey off of Earth. And that's it for T-Minus for May 1st, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. Now, we'd love to know what you think of our podcast. You can email us at space@n2k.com or submit the survey in the show notes. And your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. Now, we're privileged that N2K and podcasts like T-Minus are part of the daily routine of so many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman, and I'm Maria Varmazes. Thanks for listening.
T-minus